Howdy guys in YouTube land. Part 2 of my video. I have the keypad hooked up now. First thing I had to do, well, before I even get into that, the one nice thing about doing the display routine is you can have a little bit of fun with programming, such as that. I made a clock. Purdy. Anyway, enough screwing around. I went ahead and hooked the keypad up. What I had to do was I used the meter between here and all these functions, because this is a 5x5 key matrix. Okay? The 5x5 key matrix, because you have 5 lines going across, or 5 columns, 5 rows, whatever. But there's one thing that stands out: the power button. Well, if you look at the plug, there's 2 extra lines that I don't have hooked up right now, and those are your power button lines. It's independent from the matrix. It is not hooked into the matrix at all. It's got its own separate data lines going to that button, and the reason why it's done that way is because if you look on the original board, there's a Linear Technologies regulator, which you may not be able to see. It's LT1005CT, which is discontinued, but it's a standard linear 5-volt regulator. But there's a difference. There's a couple resistors here at the top. There's a capacitor here. Well, that line runs all the way over and into this pin block, which is going to the keypad. And the reason why that it is because this linear regulator has an on-off, latch on, latch off. So what happens is when you press the power button, it actually turns that regulator on. This regulator has a standby 5-volt and main 5-volt output, pretty advanced at the time. Now it's all switch mode, power supply, and everything else, but that was pretty advanced. And those regulators would be nice to have for homebrew projects to these days, besides using a 7805. The only difference is that high watt package can be a little bit hard to use. Anyway, so that's how the power button worked. But in my case, I'm just going to wire it to a control line on the Atmel and just do it that way. Anyway, so I went ahead and pulled up, let's see, documents. That's the folder I put it in, keypad code, and then there's the pinout. So there's the power button 1, power button 2 connection, there's the row 1, 2, 3, 4, and all that stuff. So got the debounce function in here, set up, defined my pins, and then there's my set time. There's the interrupt service routine that runs the clock, assuming the clock is enabled, because that's going to keep the score time. And then there's the subroutine, which this is actually in an application note from NASCOM or MCS Electronics for a 4x3 keypad. Well, I just copied and pasted it out of their application note and modified it for a 5x5. So, and then we got our write display function and all that crap written. It's now inside of this function now. And then here's the keypad. Basically, I'm doing an AND 31, which is the bit mask for the 5 columns. So it checks it to make sure the keys are released before it continues. So, without further ado, I'll show you what I mean by that. I'll get her all fired up. I'll go ahead and push a button. If I hold the button, the clock won't count anymore because I'm holding it. It's waiting for me to let it go. And that's key 2. It's key 23. Key 25. Key 17. Just pushing random keys. So, there you have it. And the next thing to do is get the communication code written for the UART, which most of it's there. The buffer and everything's there. Last thing to do is going to be the hardest part, is to write that one big ass state machine. So, stay tuned. Thank you for watching.